let's now summarize the trigonometric ratios of angles of any magnitude. Okay, so what I'm going to do, I'm going to do this freehand. So I'm going to draw a coordinate plane. There we go. Okay, there's our origin, there's our positive x-axis, there's our positive y-axis, and negative y-axis, negative x-axis there. Okay, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, the positive x-axis is 0 degrees, the positive y-axis is 90 degrees, the negative x-axis is 180 degrees, so that's 180 degrees measured, sort of anti-clockwise from the positive x-axis, and of course the negative y-axis is 270 degrees, and we go all the way back and sort of get back to 0, or 360 degrees, so do a full loop. Right, quadrant 1. Quadrant 1, we have sine positive, okay, cos positive, and tan positive. So this is all, okay? So that's sort of learning this all stations to central, which you may have heard of before. If you haven't, this is where it's coming from, okay? So that's all. Quadrant 2. Quadrant 2, we've learnt that sine is positive, but cos is negative, and tan is negative, so S, okay? So this is, we use the word stations to help us remember, okay? So all stations. Now, once we get to quadrant 3, okay, quadrant 3, we have sine is negative, cos is negative, but tan is positive. So big capital T there. So this is represented by the word 2, okay? And quadrant 4, okay, we have sine is negative, okay, cos is negative, sorry, cos is positive, tan is negative, and we use sort of a big capital C there, so ASTC, and we use the word central, okay, to help us remember that quadrant 4 has the cosine ratio positive and all the others negative. So there we go, all stations to central. Right, so that's where that comes from. Now, in terms of representing the angles in all these other quadrants, in terms of the acute angle, so how we deal with these kind of situations is we convert the angles in these quadrants 2, 3, and 4, we kind of pretend, or we sort of convert them into a quadrant 1 angle, but then we need to determine whether it's positive or negative, depending on which quadrant it originally came from. So if we had an angle, let's say 225 degrees, okay, which is quadrant 3, okay, if we then convert it back into an acute angle, okay, so quadrant 3, we know that tan is positive. So as long as we remember that tan is positive, and that sine is negative and cos is negative, we could just work in terms of the acute angle, but just remember to add the plus or minus sign, or the minus sign, really. We sort of assumed it's plus if you don't add anything. Just as long as you remember which quadrant it came from, that's the important thing, okay? So if this is theta, okay, so theta acute, to get to quadrant 2, this is 180 degrees minus theta. To get to quadrant 3, okay, this is 180 degrees plus theta, okay. To get to quadrant 4, we do a full loop around and then go backwards. So this is in fact 360 degrees minus theta, okay. So this will also help us to basically backtrack from whichever 3 quadrants we're in, quadrant 2, 3, and 4, and track it back to quadrant 1, and then apply the all stations to central rule, okay, to determine whether the ratio we're looking at is positive or negative. Let's have a look at some examples. Okay, so there's just 6 basic examples there. Represent the following trigonometric ratios in terms of an acute angle, and then find its value in exact form if possible, 3 decimal places otherwise. So sine of 100 degrees, the first thing we do, okay, is determine which quadrant that is. In fact, let's do this first for all 6. So sine of 100, okay, so that's going sort of from the positive x-axis around. This one should be, okay, so if I just do that, that'll be somewhere there, isn't it? So this is in fact quadrant 2, okay? Okay, in fact, I might just, okay, that's quadrant 2 there, so I don't want to mess this up. Okay, what about cos of 195? Which quadrant is that in? Okay, 0 to 90, okay, is quadrant 1. 90 to 180, okay, is quadrant 2. 180, all right, to 270 is quadrant 3. So it's a reflex angle, but it's a quadrant 3 reflex angle. What about cos of 300 degrees? So I don't really care what the trig ratio is. I just care about the angle first. 300 degrees. Well, that's again reflex, isn't it? Okay, so it's certainly not in quadrants 1 and 2. Can't be in quadrant 3 because quadrant 3 ends at 270 degrees. Okay, I might just sort of draw just a quick sort of coordinate plane there. There's quadrant 1, so that's 90, 180, up to 270. It's here, isn't it? It's quadrant 4. All right, there's our quadrant 4 angle there. Tan of 220. Okay, so that's 0 to 90, 180. 220 will line here. This is 180 to 270. So this is quadrant 3. Now, cos of negative 50, it means we're starting from the positive x-axis, but we're going backwards. Okay. In fact, anything up to negative 90 is actually quadrant 4. So there's another quadrant 4 angle there, another quadrant 4 there, and sine of 240 degrees. Okay. Well, 0 to 180, that's quadrants 1 and 2, but certainly beyond that. Up to 270 is quadrant 3, so this is a quadrant 3 angle. Now that we've determined the quadrants, let's determine whether the ratio is positive or negative. All right, so quadrant 2, all stations. So all stations to central. All right, so quadrant 2, S, it's positive. Quadrant 3 for cos, only tan is positive. This will be negative. Cos of 300, quadrant 4, positive. Okay. Quadrant 3 for tan, okay, all stations to central, that's going to be a positive. Quadrant 4 for cos is positive because it's like part C there. Tan of 240 degrees, okay. Quadrant 3, sine is going to be negative because only tan is positive in quadrant 3. So that's going to be a negative there. Now let's work out the equivalent acute angle. Okay, so sine of 100 degrees, its equivalent acute angle. So in other words, if we took the triangle from quadrant 2 and flipped it back into quadrant 1, what would that be? This would be sine of 180 degrees minus 100, okay, which is equal to sine of 80 degrees. Okay, that's not an exact ratio. In fact, because it's positive, we don't change the sign there. So sine of 80 degrees, 0.985. Okay. And we'll leave it as a positive because sine is positive in quadrant 2, so the obtuse angle for sine is positive. We use that in the sine rule. Very, very important. Okay, so we haven't looked at the sine rule yet, but when we do look at the sine rule, okay, for non-right angle triangles, you can have acute and obtuse cases. So this is why this is very, very important to know this. Cos 195 degrees, quadrant 3, it's negative. Quadrant 3, let's convert that into a quadrant 1 angle. So what we're going to do is we're going to sort of take off 180 degrees. So we're going to subtract back 180. So that's cos 195 minus 180 degrees. Okay. And that's going to be cos of 15 degrees. Okay. But because it's negative, we're going to write it as negative cos of 15 degrees. Okay. And negative cos of 15 degrees, okay, is negative 0.966. Okay, and of course, you're welcome to check this yourself. If you just put in cos 195, you should get the same answer anyway, but this is to show the working out to get full marks, obviously, and to also show your understanding. There's more to maths than just getting good results. As much as we all want to get high marks and get A grades and, band 6s and 90 pluses and all that kind of thing, you kind of fall short of the mark if you're just doing it for that reason alone. I think it's really important that you understand what you're doing first. The good marks and the good results eventually do follow. That's usually the rule, okay? So I'm not saying it's an absolute rule, but that's generally what happens. Focus on understanding. Focus on really enjoying your maths, really drawing value from what you're doing, okay? Good chance is the great results will follow eventually, okay? Cos of 300 degrees. Quadrant 4, it's positive. Let's convert that into the equivalent acute angle, or the equivalent angle in quadrant 1. So that's the same as cos of 360 degrees minus 300. Okay, so that's really the same as cos of 60 degrees. Okay, and because it's positive, we're just going to leave it as positive. Now, cos of 60 degrees, that's an exact ratio. Okay, that's the ratio 1/2. Okay, so Okay. Oh, so we'll squeeze that in there somewhere. Yeah, that's the ratio, 1:2. Okay, and it's a positive because quadrant 4, cos is positive. What about tan 220 degrees? Quadrant 3, we've determined it's positive. So let's sort of convert that back into its acute angle or its acute form. So that's really the same as tan of 220 degrees. Let's take it back 180 degrees. So it's like saying it's here somewhere, right? It's somewhere here in quadrant 3. Flip it back 180 degrees. Right, so all you're doing is you're flipping the triangle around. Okay, so just imagine a triangle sort of flipping it to quadrant 2, then flipping it around to quadrant 1. Okay, so that's really the same as tan of 40 degrees, isn't it? And because it's positive, we don't have to put a negative sign in front of that tan of 40. That's not an exact ratio, so tan of 40 is 0.839. Okay. Yeah, and I think we're happy with that. If you enter in tan of 220, just to compare, 0.839, I think we're fine. Okay, so if you ever get a question like this in an assessment, make sure not to show all you're working out, but just test it. To go back to the original question or the original expression and just compare them. Right? Very simple thing to do, but it's a good way to check. What about cos of negative 50? Now we knew that that's a quadrant 4 angle, and to convert negative angles into the equivalent positive angle, we can in fact we can add 360 to it. Okay, but adding 360 to it really gets us back into sort of quadrant 4, which we don't want. So if it's cos of negative 50, I might draw a little diagram here to show you what I'm going to do next. Okay, that's negative 50. Okay, all I want to do is I want to flip the triangle back around. Okay, so in fact, why don't you just go the other way? That's really just the same as positive 50, in fact. So that is just positive 50 degrees. I might just put a little positive sign there. So really, cos of negative 50 degrees is really the same as just cos of 50 degrees. No change. And cos of 50 degrees, and I think that's pretty cool actually, 0.643, okay, which equals 0.643. And if you don't believe me, all right, okay, just because I said so doesn't make it truth, okay, necessarily. Always, always challenge, right, what is said in the sense of, don't just accept just because it's a formula that's given to you that it must be necessarily correct. Prove it to yourself. Really make sure that you're convinced that this is correct. Okay, sounds okay to me. All right. So when I'm saying really challenge and test, challenge your own understanding. Okay, and just make sure, don't just sort of take things on face value. Really understand why this is in fact the case. All I've done is I've just flipped the triangle around from quadrant 4 back to quadrant 1. Negative 50 is really the same as positive 50 when we're talking about the cosine ratio. Okay, so between quadrants 1 and 4, there's no change. It stays positive. What about sine 240 degrees? That's a quadrant 3 angle. Okay, whoop, need a bit of space there. Quadrant 3 angle. Let's convert this into its acute angle first. So 240 is somewhere here, isn't it? So that's really the same as sort of sine 240 degrees minus 180 degrees. So what we're doing is we're winding it back half a turn. Okay, 180 degrees is a half turn. But we know that quadrant 3 is negative for sine, so we need to put a negative sign out the front. Okay, so that's really the same as negative sine of 60 degrees. Okay, we know what sine of 60 degrees is. That's an exact ratio. We've seen this one before, haven't we? So that's really the same as negative root 3 on 2. And for those who want to see this in decimal, that's obviously, negative 0.866. But this is really the correct answer because we're asked to do things in exact form where possible. Again, just test your answer, sine of 240 degrees. And if you square that, for example, you get 3 on 4, so I'm convinced that this is in fact correct. Okay, so just a quick recap. When we're dealing with angles of any magnitude or anything at all, we try and find the equivalent acute angle, okay? But while we're doing that, we also determine whether the ratio is positive or negative based on which quadrant it lies in, okay? It doesn't really matter which order you do that in, okay? I determined the quadrants first, determined whether it's positive or negative, then I found the acute angle. You can do it the other way around, it doesn't really matter. As long as you know which quadrant the angle lies or was in originally, and you maintain the positive negative nature of that trig ratio. All right, thanks for watching everyone, and wishing you all the best for your studies.